Hello, welcome back. I am Mohammed. I teach mathematics in Nigerian Tulip International Colleges. Today we are going to solve JAMB Mathematics Past question from the topic of sets. Yes, as you can see, our first question is about Venn diagram. So the information as given to us here is P complement intersection Q intersection R complement. First of all, what is the meaning of P complement? P complement means, first of all, let us draw Venn diagram. Again, let's say this is our set P, and this is our set Q, and then we have another set R. So we are going to find P complement intersection Q intersection R complement. First of all, the meaning of P complement means all the area outside P. Let me also draw the universal set, which consists all these sets, universal. So P complement all the area outside P. So I don't want to shade because there is another complement here. So all the area outside P is, as you can see, all this one is outside P. Then we are going to find also R complement. What is the meaning of R complement? All the area outside R. So that is also here, also inside P. Then we are going to find the intersection of the area outside P, outside R, and inside Q. So that is this area. Okay? So P complement intersection Q intersection R complement is this area, which is intersecting with Q. So we are looking for the area which is outside P, outside R, and inside Q. So that is option C. Okay. So let's check the next question. The next question is about, it is a two-set problem. So for this kind of question, I suggest you to draw Venn diagram. Most of the set question, if you draw Venn diagram, especially the one in word problems, your work will be easy. So let's make a Venn diagram. We have two sets here, which are reading two different newspapers. So some they are reading the champion. Let's say this is the set of champions, and some are reading the Guardian. So let's say this is their set. So the number of people that read champion, they are 40. So we don't write anything inside this set so far. So we write here, those who read champion, they are 40. Then we check the number of Guardian are what? They are 30. So we write inside here 30. Then they are asking us how many read both. So if they don't give us the number that they read both, so we start from here giving X, which is for both. So how many they read both? We don't know. We put X. Then we can find those who only read champion. So we can subtract the number they read both from the number of the champion, 40 minus X. The same thing we can do here. Those who read both is X. So we subtract from this number, we can get that one that read only Guardian. So now they give us the total number of readers is 50. So when I add all these three numbers, it should give me 50. 40 minus X plus 30 minus X is equals to 50. Then let's collect like terms. So 40 plus 30. Here you can see minus X plus X will go. Then I bring that 50 here minus Then remain here minus x. I'll send it there plus x. Now if you subtract and add here, 40 plus 30, 70 minus 50 will give you 20. So those who read both papers, that they are 20. Okay, so that is option A. So as you can see, if they give you Venn diagram, you should know how to interpret the Venn diagrams. Okay, so here they are asking us find the complement of the set of P intersection Q. First of all, let's find what is P intersection Q from this diagram. Intersection means this letter, this means common, the common area between P and Q. So that is here. Then the complement of this one. What is the meaning of complement? Outside this area. So you can take all the element outside this intersection. So which are what? We have A outside that area, B, D, and E. Okay, and then we can see this one in option A again. So our next question is, again, a word problem. So for this kind of question, we have to list. We have to write our set as a list. Okay, so the set P is all prime factors of 30. So if you like, you can write all factors of 30. You know, factor means the number that can divide 30. Okay, so let's find the prime numbers that can divide 30. 2 can divide 30. 3 again can divide 30. 5 can divide 30. They are all prime numbers. Any other prime number that can divide 30, you can check. They cannot divide. We have 7, we have 11, we have 13. None of them can divide 30 again. So set P is from these elements, 2, 3, and 5. Then let's check set Q. Set Q is all the factors of 18 less than 10. The numbers that can divide 18 but less than 10. 1 can divide 18, 2 can divide 18, 3 can divide 18, 6 can divide 18, and 9 can divide 18. So now they're asking us to find their intersection. Intersection means the common element in these two sets. So which elements appear in both sets? We are going to take it. 2, you can see in here 2. Again, we can see 3 here, 3 here. So the intersection of these two sets is 2 and 3. That is option B. Okay. So our next question is 2013. Again, it is a word problem question, which is two set again. So for this kind of question, for word problem and two set, the best way to solve is to draw Venn diagram. Okay? Venn diagram, you know, there are formulas you can apply and solve, but if you draw Venn diagram, I think it is the best way. So let's draw the Venn diagram again. We have a class of 46. Some they play football. Let's say this is the set of football, which are 22. There are 22 players in this set. Then 26 play volleyball. And then they said 3 students play both. Okay? So volleyball, we have volleyball, which they are 26. And there are some students, they are not playing any game, I think. So how many plays? Neither. So there are some students outside these two sets. Then, since they give us the number of students that they play 2 games, 3, we can just put here 3. We don't need to put X there again. So if 3 play both, football they are 22. 3 of them are already here. So you subtract 3 from 22. That is 19. Okay, then again for volleyball also the same thing. 26 are playing volleyball. 3 of them are already in common. So you subtract 3 from 26, you get 23. Now, they remain how many students that no play any game? We can write it here, X. We don't know how many that they no play any game. Now, if I add all these numbers, it should give me the total number of students, the total class, which is 46. So let us add and equate these numbers to 46. X plus 19 plus 3 plus 23 should make 46. Okay? So when we add here, 19 plus 3 is 22, 22 plus 23 is 45, x plus 45 is 46, then you collect like terms, that is 46 minus 45, and then you can see x is 1. So the number of students that no play any game is 1. Okay? So our next question again is 2013. So again, if they give you the set in this form, the best way to solve again, to make the list, to express your set in the list form. So in order to make the list, you should understand what is the meaning of these symbols, these notations. So here, it is saying that this set P is consisting such, the elements such that they are odd numbers. So the element of P, they are what? They are odd numbers which are between -1 and 20. But -1 is not included, 20 is included. So let's write the odd numbers between -1 and including 20. Okay, the odd numbers. You know odd numbers, that the numbers that not divisible by 2. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So these are the all odd numbers from -1 to 20. Okay? Then set Q, the element of set Q are such that they are prime numbers, and which are between what? -2 and less than 25. Okay? So let's see the prime numbers that are between -2 and 25. You know the first prime number is 2. So 2, 3, 5, 7, 9 is not prime, 11, 13, 17, 19, and 23. So these are the all prime numbers less than 25, okay? So we are looking for what? We are looking for P intersection Q. So what is the meaning of P intersection Q? We are looking for the common element in both sets. Okay, so which elements are in both? We can see 3, we can see 5, 7, okay? We can see 11, we can see 13, we can see 17, and we can see 19. So this is the P intersection Q. When we check the options, this is option 3, 5, 7, 11, 13, 17, and 19. Okay, okay, it's option D. Now, let's check the next question. So our next question is from 2014. So when you check this question, they give us set P, 1, 2, 3, 4, 5, and they give us the union of two sets, so P and Q, and that they gain 1, 2, 3, 4, 5, 6, and 7. So from here we can see that from 1 to 5, all these elements, they are already inside P. So remain 6 and 7, that means they came from Q. But this question is somehow is not clear. You can complain. But since in the options we have answer 6 and 7, we can accept. Okay, so that is option B. So our next question, let's check our next question. Our next question again is from Venn diagram. They shade some part and they want us to find what is the meaning of this shaded part. So for this kind of question, we need to know intersection and union. Okay? So while you check this question, you see that, so you have to analyze one by one. What is the meaning of this area? For example, this is P, when you check this area, this shaded area here, is P intersection R, where the P and R intersect. Then if you check this area, P intersection Q, where P and Q intersect. Then what happened? They combine these two shape. They combine these two areas. So that means they unite. They unite P intersection R with P intersection Q. Okay? So that is option B. P intersection Q, union P intersection R. Okay? Again, they describe the set, but they don't give you element in 2015. So for this kind of question, again, to see information clear, to solve it better, you need to write your element in the list. You should make the list of your elements. So we can write set U, which is universal set. You know universal set is important. You should write universal set. When you write your universal set, the remaining set, you will take the element from inside this universal set. You cannot exceed the universal set. So that's why to understand universal set is important. So what is universal set? All even numbers between 0 and 30. So let's write them. 2, 4, 6. You know, even numbers are the multiples of 2. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Because they say between, that means we not take 0 and 30. 0 and 30 also are even numbers, okay? Then set P is multiples of 6 between 0 and 30. So multiples of 6, which is 6, 12, 18, 24, and 30. We don't need to take 30 because 30 is not inside, let's say between. Then Q is multiples of 4 between 0 and 30. So we can take 4, 8, 12, 16, 20, 24, and 28. Now, they ask us to find P intersection Q, the complement of P intersection Q. First of all, if you want to find the complement of P intersection Q, you need to find P intersection Q first. So let's find P intersection Q. What is P intersection Q? We are uniting all the elements in P and Q. So let's write in order. So inside Q and P, whatever you see different, write them. But the one they are common, you don't need to write 2 times, only write once, okay? You can write common elements, but not 2 times, only once. Okay, so let's write 4, 6, I'm writing in order 8, then we have 12, we have 16, we have 18, we have 20, 24, and 28. Now, what is P union Q complement? So, if you write the P union Q, it's easy for you to find the complement. Now we are checking the elements that are inside the universe but not inside P union Q. That is the meaning of complement, P union Q complement, okay? So we are checking the elements that are not inside this P union Q, but they are inside universe, universal set. So 2 is not here. We cannot see 2 here. We cannot see 10. Then we cannot see 14 inside this set. We cannot see 20 is here, 22. Then we cannot see 26. So this is the complement of P union Q. Okay? So that is option 2, 10, 14, 22, and 20. That is option C. Okay. Now let's go next question. Our next question is, asking us to find how many students that play 2 games. How many students that play 2 games? Let me explain briefly for you what is each area means. First of all, if you have a Venn diagram, the elements that is outside, this means that the student that not play any game. So 10, they not play any game. The student that are inside only one set, you can see. When you draw your line, this 7 is only inside volleyball. So this student play only 1 game. This 7, 6, and 10. So if they ask you how many they play only 1 game, you take this part. You take these ones. Then those play 2 games. We check the one that they are inside 2 set. Inside border of 2 set. When you check hockey and volleyball, you see that these 8 are only inside 2. They are only inside volleyball and hockey, these 8. So we are going to find the student that play only 2 games. We take this one, 8. Then this one, they are playing only volleyball and swimming, which is 4. And this one too, they are playing only hockey and swimming, so plus 3. So the student that play only 2 games, they are what? 8 plus 4, 12, plus 3, 15. 15 students play 2 games. I hope you understand. Then this one that is most inner, this one here, play 3 games, okay? So this one, 3 games, this, 2 games, this one and this one, they play 1 game. The one outside all the set is playing no games, okay? Okay, this is our last question, I think. Thank you very much for your time.